0.13 second for the system. This is mind blowing. This is truly mind blowing. This is, I mean, you try to compare 0.13 seconds with a 36.16 seconds, and this is again a same implementation, guys. I'm not using like any different library or any different tool. This is the same implementation I'm using of the Genson version of the Python, and for the Rust also I'm using the Genson-RS. The Rust implementation of a Genson, this is a library which is trending really good on the various social media platform, and this is the hard thing going on. It really caught my attention, and that's why I decided to make this video. So Genson-RS, this is the Rust implementation of the Python library, and what this library does, it is basically a JSON schema parser. So as you can see, that generated JSON schema from the gigabytes of JSON data in seconds. Genson-RS is a Rust rewrite of the Genson Python library, which can be used to generate a JSON schema draft for and after from one or multiple JSON objects. While not having full features parity, Genson-RS focuses on the speed. It offers much better performance, 25x to 75x faster compared to the Python Genson library. Wow, this number is not usual, guys. Let me tell you, like, rewriting a library from one language to another and results being 25 to 75x faster. This is a tremendous achievement as a rewrite project, I would say. And I think this is gaining a lot of attraction. I see like it has been released just 2 days back, and it managed to gain like a 56 stars within a like less period of time. So this is a hard shit that is going on. So that's why I decided to try out this thing and see the results on my own. So what I have did is like I have downloaded the JSON with a pretty big large files. As you can see that even that is not able to open in my VS Code because it says that tokenization, wrapping, folding, code lengths, word highlighting, and sticky scrolls have been turned off for these large files. This may reduce, sorry, this to reduce the memory usage and avoid the freezing or the crashing. Smart decision, VS Code, you're not capable of that. Okay, so I have a really big files. I have like 100k records, 10k records, 1 million and 1.7 million, and that are really humongous. If I show you, I managed to download them from this site which actually provided me those files. So as you can see that it has like 10k records basically have 3 MB of size, 100k has 29.7 MB size, and 1 million is basically 296 MB, and the maximum that I have is 543 MB. But I think that's still not good load for the Rust. Okay, so we'll see the results, like how it performs for Python, how much time it takes, and for Rust how much it takes. But the reason I'm telling like this is not really a actual load for Rust, so this is already a spoiler for you guys, like what Rust is capable of doing the things in a faster way, in how much faster way. Okay, so what I did is I installed the Json library. I'm using the Poetry package manager for the Python, and I have 1.3.0 version. And I wrote a simple script. That script basically uses the Json to read the JSON files and then basically parse the things from the JSON, and then ultimately it prints out the time. So we are talking about like the JSON parsing. What exactly is the use case of the JSON parsing? So the JSON parsing is actually a widely used application in the many programs. So as a developer, you need a JSON parsing. So basically it generates you a output of the JSON schema. You provide the large number of the JSON data, then it gives you like what is the schema of it. This has a really good application in terms like when you are the API which is returning some API or the endpoint or some backend service which is returning a lot of data, and you want to know like the structure of it and then design your type system which will fit into that. This plays a vital role in it. It's not just about your HTTP and the web service architecture, like applications are not restricted in that domain, but having a tool that basically pass the JSON content, JSON data, and derives the structure schema of that JSON, it has a very wide range of applications. As you can see in this example that like you have provided some JSON data and it gives you a schema for that. So it generates output like this schema. You have the ID, then the title, description. It also tell you like what is the type of it, then what are the mandatory properties, if it is required or not, that sort of stuff. Optional, it also specified that. So this kind of structure, this kind of output, what we call as a JSON schema. This is a really good example. You provided the JSON object and gives you like a properties are this product ID, type is integer, this is the description, product name, and this is the type as a string, price, then the type. This is the powerful library and it has a ton of application. So what I understand is passing a JSON data and forming a JSON schema out of it. It has a wide range of application, and when your data tend to grow, then you need a tool that basically suits the this high scale, this humongous data, and that's where Json-RS is doing that job, and that's why it's gaining a popularity. Okay, so let's back to our code. So I have this Python script which basically accepts the file name of the JSON and then passes it and gives a nice output of the JSON schema. And also I intentionally put a time there to find out like how much time it is taking for the whole passing operation. Okay, so it is time. Let's see the results. So we'll start gradually. So what I will do first is I will execute it on the lower data. So I'll remove the 1 million and we'll just say, okay, I just want to pass a 10K record. So we'll go gradually. So I'll just pass it for the 10K records. So Python JSON parser.py, and it managed to pass that really fast. Parsing time was like 0.13 seconds, which is actually very less, nothing. Now let's do a same with the Rust. So Genson-RS, and then I will pass the path. So it has to be like this: data slash and then users. I have capital U users 10K JSON, and it also did that. And apparently I forgot to put a time in front of it, so I can just modify my command like this: time Genson-RS, and it took me like 0.07 seconds, user 0.01 seconds, system 368 CPU percentage users. So it was pretty fast. Okay, now let's come back and increment this. So from the 10K we'll jump to 100K now. So let's run. So let's run it on the 100K now. So we'll do a Python JSON parser, and for 100K it actually took some time. So parsing time for 100K record was 1.49 seconds. Okay, and let's see how does Rust perform for the 100K records. So time and 100K here this time. And for Rust I think it's pretty fast again. It just took like a 0.01 second for the system, which is again the same what it took for like 10K records. So I say absolutely no difference here. Like scaling that from 10K to 100K, Genson-RS, it had a zero difference in a time taking for processing a record, which were basically 10 times higher. So this is staggering to me, and this is mind blowing. Okay, now let's bump up the records again. So I will increase this to 1 million now. So let's see how does Python handles the 1 million record. So Python JSON parser.py, and for 1 million I think Python actually gonna take some time, because I know this is a lot of data and Python basically is not, and I have heard and I know like Python doesn't work well with a huge data sets. So passing time for 1 million records was 18.95 seconds for the Python script using the same library what we have. Okay, now let's see the same results for the Rust version of Genson. So I'll pass 1 million. Wow. And for the Rust version, it took just 0.07 seconds. I mean, see, here for the 1 million records, Python took 18.95 seconds. Rust just took 0.07 seconds of the system. For the user, it is 3.34 seconds. But still, that difference is so much, so much. That's why I now understand why they mentioned that it offers much better performance, 25x to 75x faster compared to the Python JSON library. And this is the actual statistics what we have just proved now. Okay, I am already impressed by the Genson-RS. So now we come to the final test. Let's give the humongous data, the maximum that I have here. So I'll put 1.7 million, and let's see how it performs. This is the maximum data I have, which is around 502 megabytes something. I wanted to try it with a gigabytes of data and see the results. I know Python definitely gonna crash there. It is gonna not gonna perform. It is gonna take its hell lot of a time. but with the Genson-RS, I want to give that a try. So let's go, and I have modified to the 1.7 million, and let's run the script again. Python JSON parser.py, and now I have the maximum data what I have in my data folder, which is 1.7 million records, 502 megabytes of file, and it is taking a time. Wow, and after 36.16 seconds, it finally printed the pass station schema. So this is how it generates a schema. And this is what I was talking, like this schema has a variety of application in deciding like what kind of a data you have. And depending on the schema, then you can basically write a processing logic in your application. It has a wide variety of applications ranging from the mathematics to like just doing any simple web application. But the passing time is 36.16 seconds for the 1.7 million records in the Python. And now let's give a final load test to our Rust with a 1.7 million records, and let's see. And Rust is never disappointing me here. See the CPU percentage here. It says 427 percentage of the CPU, 0.13 second for the system, and 0.13 second for the system. This is mind blowing. This is truly mind blowing. This is, I mean, you try to compare 0.13 seconds with a 36.16 seconds, and this is again a same implementation, guys. I'm not using like any different library or any different tool. This is the same implementation. I'm using a Genson of the Genson version of the Python, and for the Rust also I'm using the Genson-RS. To just confirm to you guys, I'll just show cargo install list, and it will print the list of the libraries, Rust library that I have installed, and I have only one Genson-RS, which is 0.1.0 version, same as what I have here. It just released 2 days back. So I think Rust implementation is truly awesome here. Well, I am not a Rust expert actually. I don't know a shit about Rust. I have not even write a hello word in a Rust yet, but I know how Rust work. I know the basics of the memory allocation and the programming principles of the low level language. When I started learning computer concept, data structure and algorithm, I started with a C and CPP. So I know like how this low level programming languages work, the way they handle the memory allocation, usage of pointer, the structure, and the dynamic memory allocation. Those things are really mind blowing. And when it comes to an application like this actually really outperforms to a something, for a high level languages like the Python or the JavaScript. By the way, we also have a JavaScript implementation of the Genson. I have given a try to that also, and the result were almost same as a Python. That's why I want to just skip that part and not show you the stats of in the JavaScript. So now a question comes to mind, like how does it manage to do that? What techniques actually it utilize? So they have provided the benchmarks also, and then the optimization techniques. So we will see like how they actually manage to do this. So reasons they have provided for like this huge optimization is Rust being blazingly fast itself. Of course, they are using a Rust. So without any GC or interpreter overhead, one-to-one port in a Rust running on a single CPU core runs twice faster than the Python version already. So like implicitly Rust is pretty faster. So whatever you're going to write in a Rust, that will perform twice faster than what you have in a Python. So yeah, you have the advantage of the language itself. Parallel processing leverage the available CPU cores. While Python has a limitation of the GIL that prevents it from the leveraging multiple CPU cores efficiently, Genson-RS parallels the map reduced type of workload whenever possible when processing gigantic arrays, mixing out of all the available CPU cores. Okay, so two things we understand. It managed to use the multiple cores, and it uses this technique called map reduce. So for those of you who don't know map reduce, it's like basically dividing these chunks of data into a smaller part, and then performing those computation individually independently and merging them at one point to get a final result. Extremely fast JSON passing powered by the SIMD instruction. Instead of fully passing out the whole JSON data, we use the SIMD JSON library or Rust port of the C++ CMD JSON library that leverages the SIMD single instruction multiple data instructions to only pass out the type of the JSON dataset, which is sufficient enough to build the schema on top of the without any deserializing a whole data set. Now here we are talking about the low level programming. So SIMD instruction is something that I learned in my university graduation, that you have some instruction that basically allows a single instruction and multiple data from the assembly language. I also wrote the assembly language code for some simple programs like doing a multiplication and addition, so I remember it from that. uh, but I never applied that actually in my real on the project that I was working. In short, like, it has, as I was saying, it has that advantage of leveraging the low level programming concepts like the SIMD instructions or the memory allocation things. Talking about the memory allocation, that's what our next point is: efficient memory management using the MI malloc allocator. This is the recommended by the CMD JSON library itself. Genson-RS opts to use the MI malloc allocator instead of the default global allocator, which made the code run fast by a decent amount. So memory allocation is the key here. So let's see what exactly MI-malloc means. So it is a general purpose allocator with the excellent performance characteristics initially developed by Dan Legion for the runtime systems with the Coca and Lean, blah, blah. Okay. But what it does, it is a free and open source compact general purpose library that is around 11,000 of line of code, and it's developed by Microsoft with a focus on performance characteristics. So malloc is a function that I was aware about. I have used it in long days back. But this is the enhanced memory efficient, memory performance optimized version of the malloc mi malloc. So I can't imagine like how fast it would be. Honestly, again, I am not a Rust expert, but I know few things about the low-level programming language, the way the instructions and the memory management is done. So that's it for this video. I wanted to show a demonstration of how fast the version, Jensen implementation of the Rust is. And I guess with this demo, we literally prove that. If you have any question or the comments, do let me know them in the comments. And thank you for watching this video. Have a nice time.